Download this code from codegive.com, link in the description below. OK, let's dive into analyzing HTTP responses from REST APIs. This will be a comprehensive guide covering various aspects, from understanding the structure of HTTP responses to practical code examples in Python. Understanding HTTP responses, the foundation. When you make a request to a REST API, you send an HTTP request, example using GET, POST, PUT, DELETE. The server processes this request and sends back an HTTP response. A typical HTTP response has the following components. 1. Status code ***, a 3-digit integer that indicates the outcome of the request. It's the first thing you should usually check. 2. Headers ***, metadata about the response itself. Headers can provide information about the server, the content type, caching instructions, authentication information, and more. 3. Body, or payload, the actual data that the server is returning. This can be in various formats like JSON, XML, HTML, text, or binary data, images, PDFs, etc. The content type header tells you how to interpret the body. Status codes, a quick reference. HTTP status codes are grouped into categories based on their first digit. *1XX, informational, the request was received and is being processed. You rarely encounter these directly in typical API interactions. *2XX, success, the request was successful. *200 OK, the standard success code. The request was successful, and the response body contains the requested information. *201 created, the request was successful, and a new resource was created, often in response to a POST request. The location header might indicate the URL of the newly created resource. *204 no content, the request was successful, but there is no content to return in the body. This is often used for successful delete or put requests where you don't need confirmation data. *202 accepted, the request was accepted for processing, but processing has not been completed. The request may or may not eventually be acted upon, and may be disallowed when processing occurs. *3XX, redirection, the client needs to take additional action to complete the request, example redirect to a different URL. *301 moved permanently, the requested resource has been permanently moved to a new URL. Clients should update their bookmarks and use the new URL. The new URL is often found in the location header. *302 found, or 307 temporary redirect, the resource has been temporarily moved to a different URL. Clients should use the new URL for this request, but should continue to use the original URL for future requests. *304 not modified, used for caching. If the client has a cached version of the resource and sends a request with an if modified since or if none match header, the server can respond with 304 if the resource hasn't changed. The client can then use its cached copy. *4XX, client error, the request contains an error, example bad syntax, missing authorization. *400 bad request, the server cannot understand the request due to malformed syntax. *401 unauthorized, authentication is required, but the client has not provided valid credentials. You need to provide an authorization header. *403 forbidden, the client does not have permission to access the resource, even with valid credentials. This is different from 401, it means the server understands who you are, but you're not allowed. *404 not found, the requested resource could not be found on the server. *405 method not allowed, the HTTP method, example POST, is not allowed for the requested resource. Asterisk 409 conflict, the request could not be completed because of a conflict with the current state of the resource, example trying to create a resource with an ID that already exists. Asterisk 429 too many requests, the user has sent too many requests in a given amount of time, rate limiting. Asterisk 5xx, server error, the server encountered an error while processing the request. Asterisk 500 internal server error, a generic error message indicating that something went wrong on the server side. Asterisk 502 bad gateway, the server, while acting as a gateway or proxy, received an invalid response from an upstream server. Asterisk 503 service unavailable, the server is temporarily unavailable, example due to maintenance or overload. Asterisk 504 gateway timeout, the server, while acting as a gateway or proxy, did not receive a timely response from an upstream server. Analyzing HTTP responses with Python, requests library. The requests library in Python is the standard for making HTTP requests. Here's how you can analyze the responses. Explanation asterisk. 1. Import libraries asterisk. We import requests for making the HTTP requests and JSON for working with JSON data. 2. Make the request asterisk. Requests.get, API _URL, sends a GET request to the specified URL. You can use other methods like requests.post, requests.put, requests.delete, for different types of API interactions. 3. Check the status code asterisk. Response.status _ code gives you the integer status code. We use if/elif/else to check for different ranges of status codes: success, client error, server error. 4. Analyze headers asterisk. Response.headers is a dictionary-like object containing the headers. We iterate through the headers and print them. Pay close attention to content type to know how to interpret the body. 5. Analyze the body asterisk. Asterisk JSON asterisk. If content type is application/JSON, we use response.json to parse the JSON data into a Python dictionary. We then use JSON.dumps with indent =4 to pretty print the JSON for readability. You can then access specific data within the dictionary using its keys, example data name. Include error handling for the case where the response is not valid JSON. Asterisk XML asterisk. If content type is text/XML or similar, you'll typically use the xml.itree.elementtree library, or LXML for more advanced XML processing, to parse the XML data. I've left a placeholder in the code. Asterisk HTML asterisk. If content type is text/HTML, the body will be HTML markup. You can use libraries like Beautiful Soup to parse and extract information from the HTML. Asterisk other content types asterisk. For other content types, example plain text, images, you can access the raw content using response.text, for text-based content, or response.content, for binary content, like images. 6. Error handling asterisk. Asterisk try, except blocks asterisk. We wrap the code in a try, except block to handle potential errors. Asterisk requests.exceptions. Request exception catches general network errors, example connection refused, timeout. Asterisk requests.exceptions.http error catches HTTP errors, 4xx and 5xx status codes, that are raised by response.raise _for _status. Asterisk JSON.JSON decode error catches errors that occur when the response is not a valid JSON. Asterisk exception, a general catch-all for other unexpected errors. Asterisk response.raise _for _status **. This is a crucial line. It checks the status code and raises an HTTP error exception if the status code indicates an error, 4xx or 5xx. This allows you to handle errors consistently in your code. Important considerations and best practices **. API documentation ** always refer to the API documentation for the specific API you're using. It will tell you the expected URL endpoints, the required HTTP methods, get, post, put, delete, etc. The expected request headers and body format, example JSON. The possible status codes and their meanings. The format of the response body. Authentication requirements, API keys, OAuth, etc. Rate limiting policies. Authentication Many APIs require authentication. You'll typically need to provide an API key, use OAuth, or some other authentication mechanism. The requests library makes it easy to include authentication headers in your requests. Rate limiting APIs often have rate limits to prevent abuse. If you exceed the rate limit, you'll typically get a 429 too many requests error. The retry after header may tell you how long to wait before retrying. Implement logic in your code to handle rate limiting gracefully, example by pausing requests for a certain period. Content negotiation Some APIs support content negotiation, where you can specify the desired response format using the accept header. For example, you might set accept application/JSON to request a JSON response. Error messages in the body Many APIs include detailed error messages in the response body when an error occurs, example in a 400 bad request response. Be sure to parse the body and log or display these error messages to help you debug the problem. Logging Use logging to record requests, responses, and any errors that occur. This is invaluable for debugging and monitoring your API integrations. Idempotency If you're using methods like put or delete, consider the idempotency of the operations. An operation is idempotent if performing it multiple times has the same effect as performing it once. Design your code to handle potential failures and retries gracefully, ensuring that your API calls don't have unintended side effects. Asynchronous requests For performance-critical applications, consider using asynchronous HTTP requests, example with the Asyncio and IOT libraries in Python, to make multiple API calls concurrently. Example, handling a POST request and analyzing the response. Key improvements in the example. Post request The code now makes a POST request using requests.post. It passes the data in the data parameter, which is automatically serialized to JSON, because of the content type header. Content type header It sets the content type header to application/JSON, indicating that the request body is in JSON format. This is crucial for the server to correctly parse the data. 201 created handling The code now checks for a 201 created status code, which indicates that a new resource has been successfully created. It also attempts to read the location header, which often contains the URL of the newly created resource. Detailed error handling The code includes more detailed error handling, including printing the error message, if available in JSON format, for 400 bad request errors. Remember to replace the placeholder API URLs with actual API endpoints for testing. Also, Carefully consult the API documentation for the specific API you're using to understand the expected request and response formats, authentication requirements, and error handling procedures. Good luck.